How does BLE technology help an IoT irrigation system? Join me on this episode as I show you how to get started with the Fiore board, an IoT irrigation demonstration kit featuring key components from STMicroelectronics like MCUs, sensors, power and wireless communication devices. Hi, welcome back to TechVentures. My name is Lazina and I'm a technical marketing engineer at Fiore Electronics. If you're interested in checking out any previous TechVenture episodes, then please feel free to click the link on the screen or check out the description box below. Fiore is an IoT irrigation demonstration kit designed by Fiore Electronics in partnership with STMicroelectronics. The Fiore platform consists of two boards with key components like an MCU, sensors, power, and wireless communication devices manufactured by STMicroelectronics. The main board, which is shaped like the watering can, senses the soil moisture levels and automatically communicates with the companion board, which is shaped like the flower board. The latter controls a submersible water pump to start and stop watering the plant. The companion board also contains motor current monitoring, tank water level monitoring, and leak detection functions. We can wirelessly access the irrigation system via Bluetooth to get real-time sensor data, including humidity, temperature, and pressure. But we'll talk about that later. Today, I'm going to show you how to get started with the Fiore IoT irrigation system. In the box, we have the main board that's shaped like a watering can, the companion board that's shaped like a flower, water hose tubes, a thin tube, an electrical wire pair, a little plastic plate, a manifold, and a submersible pump, a 10-pin wire flat interface cable. We will also need to download the STBLE Sensor Classic app and the NFC Tool app. To put all this together, first we need to assemble the water leak probe. On the Fiore mainboard, notice this little rectangle that says water leak. You can break off the board. It's recommended to use cutters or an X-Acto knife. I have one that's been already prepared. Grab the small plastic plate and align the two center holes of the PCB with the bottom side of the water leak detector board probe. I've already got another board that's prepared and it should look like this. Connect the electrical wire pair to the water leak probe. You can split the wire pair at one end for a length of approximately 1 inch. Insert these two wire ends fully into the IDC connector. There's no need to strip them and there's no polarity, so you can insert any wire at either position. When both are fully inserted, press down firmly on the top part of the IDC connector until it is fully seated down in the bottom part to make the connection. I've already done it before, so this is what it should look like once completed. And then strip the opposite free ends of the wires and connect the other ends into the companion flower board at terminal block J2, which should go over here. There are no polarities, so we can connect the wire at any position. The water leak detector probe would typically be installed near the bottom of the flower pot, that is, wherever the watering can will be watering the plant. Next, we need to assemble the water hose and pump. Connect one end of the thicker hose to a port opening of the plastic manifold, like so, and connect one end of the thinner hose to the matching port of the plastic manifold adapter. Connect the free end of one of the thick hoses to the submersible water pump output port, like so. Next, using the 10-pin flat wire interface, connect the watering can to the companion flower board and verify that pin 1 goes to pin 1 at each end. Connect the water pump's electrical wires to the connector J1 on the companion board. Make sure to connect the red wire to the positive pin on J1 and the black wire to the negative pin. Next, we're going to connect the thinner hose to the pressure sensor port on the companion flower board. Make sure to insert it fully into the hose to avoid leaks. If you're operating the demo with water, always verify that the tube remains fully seated, especially after handling the board, as water may flow out of the hose when the pump is activated. On the main board, which is also the watering can, make sure the power switch is set to the off position and insert 3 AA alkaline batteries in the battery holder. Alternatively, the system can be powered through the Type-C USB connector. This concludes the hardware assembly. Now let's see this in action. I've got a container filled with water, and this represents the water tank. I've already put the submersible pump inside. It's connected to my flower companion board, and the other terminal block is connected to the water leak detector. We'll put this in the flower pot to simulate detecting an excess of water. The flower board typically rests above the water container to monitor the level. So I've got the plastic manifold inside the container, and for demo purposes, I've got the water hose putting the water back into the container. We wouldn't want to mess over here. It's going to be pretty hard to clean up. And the free end of the thin hose is connected to the water pressure sensor port, as I mentioned before. And just to put it all together, the watering can is connected to the flower companion board through this 10-pin flat wire through this interface again. The main board electrodes have been placed into the soil for moisture level detection. For demo purposes, these are very short. In reality, they would be made much longer to sense soil moisture at a greater depth. Let's just double check that all the electrical and water hoses are connected. Before powering on the system, especially the first time, be ready to power it off quickly in case there are water leaks. Switch on the system by sliding the switch to the on position. At rest, the flower board continually measures the water surface distance using a time-of-flight sensor and indicates if the water level is too high or too low by blinking its RGB LED accordingly, and it's located at the bottom of the flower board over here. But I'm going to demonstrate it onto this side so that I can show it better to you. Red blinking means that there is low water level. No blinking means normal water level, and yellow blinking means high water level. So out of the box, the default mode is set to manual irrigation mode. The irrigation mode can be changed between manual and automatic by writing a text record via the onboard NFC tag on the watering can right over here. To see the currently set irrigation mode, read the NFC tag with your phone or tablet. This can be read while the watering can is powered off or powered on. In manual mode, the pump is solely controlled through gesture detection via the time-of-flight sensor on the watering can board, using the tap or swipe gestures. In automatic mode, the pump is controlled automatically via the moisture sensing probes, otherwise known as the legs, of the watering can board. The automatic mode can be temporarily overridden manually by gesture detection via the time-of-flight sensor, and to start the pump manually, do a single tap gesture toward the time-of-flight sensor on the watering can. The pump will start and run for a maximum run time set to 10 seconds, and then time out for 10 seconds before it can be activated again. This avoids accidental overwatering or spillage. To stop the pump manually when started with a start tap gesture, do a single swipe by passing your hand over the sensor once in any direction, and to stop the pump manually when it was started automatically, tap, then swipe.
A feature that might be interesting to know is that the time-of-flight sensor on the watering can board has an integrated ambient light sensor. In this out-of-the-box demo, the ambient light level is monitored every 10 seconds. If the ambient light level is below a preset level, the relay will be automatically activated, for example, to turn on an external LED light.
The Fiore ecosystem showcases the STM32WB module. I have a video explaining the module more in depth. If you're interested, you can check out the link in the description box below. Earlier, I mentioned we'll need the STBLE Sensor Classic app. Let's go ahead and open it. The app helps facilitate various sensor readings on the main board. The app is provided by STMicroelectronics, and we're using it as it was found on the Google Play Store and Apple App Store. It's easy to use and no code modification was needed. We're able to see our actual sensor data on the app. Of course, we need to enable Bluetooth and location services, so please make sure it's enabled. Once you're done that, you'll be greeted with a screen like so. Select Connect to a device. You should see your Fiore board populate as WB5MDK. Please select that. The demo by default displays the environmental section. This section allows sensor readings for ambient temperature. I want to point out that there's a toggle switch to convert between Celsius and Fahrenheit degrees easily. The sensors also give readings for water pump pressure and soil moisture humidity. Select the three lines at the top left-hand corner next to the word environmental to see the other demos available. An interesting feature is the watering can or the main board has a relay connector. The LED control section of the app controls this relay. I've got mine connected to a beautiful sunflower. If I touch the LED icon on my screen, it lights up on the app, and my sunflower gets some sunshine too. And if I select it again, it's off. Oh, the sunshine is gone here too. Well, there you have it. Now you know how to get started with the Fiore board. If you'd like more information about the smart irrigation system, then please feel free to reach out to your local Fiore Electronics representative or visit us online at fioreelectronics.com. Thanks for watching, and I'll catch you next time on TechVentures with Lazina.